Hello, everyone, and welcome to another episode of Containers from the Couch. Today, we've got an exciting episode for you. I'm thrilled to have two guest speakers today from Stackwatch, creators of Kubecost, the CEO himself, Webb Brown, and Sean Pomeroy. So something about Webb, he's not only the nicest, one of the nicest leaders I know, but also one of the most effective leaders. And you wouldn't be able to tell from looking at his webcam, but he's also really tall. Webb, how tall are you? And by the way, thank you for coming on the show today.
It's an honor to be here. I'm claiming 6'4", 6'5". I'm actually neck and neck with a number of folks on our team. We've got a tall team. But yeah, it is such a privilege to be back here. Thank you so much for having us today.
Awesome. Thanks for joining us, Webb. And Sean, I was kind of trolling your LinkedIn earlier, and I saw that you like tinkering with home automation and you like working with cars. Dude, we would get along. We should chat after the show today. But Sean's going to be our demo extraordinaire today, showing us exactly how Kubecost 2.0 works. So, Sean, thank you for joining us.
Thanks for having me, Sai.
Absolutely. So, Webb, I want to start with you. With any 2.0 release, that's a major deal. And you know, with Kubecost specifically, we know that this comes with a number of new features. And I'm guessing, you know, steps for migrating for customers to move from 1.0 to 2.0 as well. Tell us a little bit about Kubecost and why we're making a 2.0 release. Tell us a little bit about it.
Yeah, absolutely. We have a ton of new stuff to unveil live for the first time today, and it's a super exciting time. If you think about 2.0 for us, it's essentially a new product. An entirely new API backend, entirely new data store. Sean's going to talk a lot about, but fundamentally just a huge transformation for us as a product from an architecture standpoint, et cetera. On top of that, we've got 12 plus major new features that we're going to spend a lot of time demoing live today. And we also have a really big announcement for EKS users in particular. So before we dive into that, which we're going to get to really quickly, I just want to set the stage, give a little bit of background context on Kubecost. So first and foremost, Kubecost is a comprehensive cost management solution purpose-built from the ground up for teams running Kubernetes. So it has real-time cost visibility, optimization, as well as governance built into its core product. It comes with deep insights into Kubernetes spend, but it also gives you visibility into related cloud consumption. So if your Kubernetes workloads are communicating with S3 or RDS, et cetera, we're going to be able to talk about that relationship, but also show you that spend specifically with those external cloud services. And everything in Kubecost is built on top of the CNCF project OpenCost, which we contributed a little bit more than a year ago and is actually up for incubation review right now. And so if you look at Kubecost today, it's currently available to all EKS users. It's in use today by thousands of teams on the platform. If you look at the ECR images and the Helm chart that's available, it's now been pulled more than 5 million times since we launched the EKS optimized bundle. So it's been amazing to see so many teams and users getting value out of it. And it can be installed in seconds via Helm and images in ECR. You can check out the link in the description on how to go get that now. You can also just go to kubecost.com and install it from there. And we are working on bringing it to getting the EKS add-on and AWS Marketplace listing updated as we speak. So expect that really soon. And then one of the really big announcements we have to make today is that we are super proud to announce that as part of Kubecost 2.0, the EKS optimized bundle is getting a dozen plus major new features, all for free, unlimited clusters, unlimited nodes, We are super, super proud to announce this here today with you, Ty, and in this close collaboration with many teams at AWS.
Free is good. You love to hear free. Now, I was catching up on, the EKS optimized bundle, and I know by default you can get up to 15 days of data storage. Can you talk a little bit about that?
Yeah, definitely. So we support a number of integrations with the EKS optimized bundle. So first is by default, Kubecost would communicate with a local Prometheus. It comes bundled with a really lightweight Prometheus that's just scoped for kind of cost and utilization metrics. It can also be integrated with a custom Prometheus. So the underlying Prometheus can retain data for an unlimited time period. The API built on top of that data by default retain data for 15 days. We also support an integration which we announced last year with Amazon Managed Prometheus, and very similar setup there, where unlimited or configurable as long as you like metric retention and AMP, and then our APIs would just be built on top of that managed Prometheus service.
Awesome, excellent. And I heard I was getting a little bit of voice crackling, so hopefully I got that fixed. Okay, Webb. So that makes a lot of sense. So a lot of new features. Can you talk a little bit about what some of these new features are that Sean's going to help demo for us?
Absolutely. I think that's a cue to get straight to action time. There's kind of 5 key areas where we plan to focus today. I mentioned how we built an entirely new API backend, introduced a new OLAP data store that enables a bunch of new functionality, but also 100x performance improvement at scale, significantly lower metric retention on, in most cases, it's 2 to 3x, resource consumption at scale. So Sean's going to talk about that and how it impacts, core functionality as well as adds, new functionality. A lot of new stuff around cost network monitoring. So the ability to visualize relationships between not just Kubernetes workloads in the same cluster or across clusters, but also with external cloud services and egress to the wide internet. Sean is going to demo and unveil our new collections functionality, which is a robust set of functionality that introduces new intersections of Kubernetes cost data and cloud costs. So you can see kind of the entire cost of a tenant, a team, a project, et cetera, et cetera. I'm going to unveil Kubecost actions, which are in GA, which are new automated workflows for cost optimization, and then a bunch of brand new functionality around forecasting costs, both Kubernetes as well as cloud costs, and also anomaly detection. So again, all these available today in 2.0 and more, all available free in the EKS optimized bundle now.
Excellent. Love to see it. Sean, you've got your work cut out for you here. Hopefully you saw this list of demos before Webb went through it. Let's pass it over to you. We'd love to see this in action.
Yeah, sounds good. Say Webb only stole a few of the things that I was going to say, so I think we'll be all right.
You'll say them much better. I know that. You always do. You always do.
From my perspective, the new backend is absolutely huge. Obviously, a lot of it's not directly visible within the platform, but I think anyone that's used Kubecost in the past and is upgraded to 2.0 will be very pleasantly surprised with the speed and efficiency that the queries are now returned. So we can kind of highlight some of that today. For those that have not seen Kubecost, right, this is the main allocation screen. So this is basically, when you want to understand the cost of your workloads running in Kubernetes, this is the view that you would use. Right now, we're looking at the last 90 days worth of data. One of the cool features that we got with the new backend is autocomplete. So if we want to add a filter, we can very easily come into here. I'm going to filter by namespace. So let's pick on our Acme Fitness demo. You see it's pre-populated my list of available values here. And now it's dynamically updated the view below specific to that namespace and the cluster that I'm looking at. And of course, we haven't lost any functionality with the new upgrades to the platform, so we can still drill into this namespace and essentially follow the hierarchy of Kubernetes, right? So basically drilling in a namespace, we're looking at all the controllers within, we see all the costs represented by CPU consumption, GPU, RAM. We can drill into a specific deployment in this case and see all the pods that have spawned from that deployment. And then ultimately ending up at the container level, which is where the cost model or even that open cost piece of software runs to figure out the cost of the workloads running within Kubernetes. And to do that, we use a combination of data points. So namely the cost of the underlying node, right? Does it have EDP associated with it too? Is it a spot node? Is it an RI or savings plan applied to it? The window of time the container has run for. So we see 864 hours over the last 90 days. And then a combination of your container advisor and KSM metrics to let us know what the container is requesting from a capacity standpoint and what it's actually consuming. And then we take the maximum of those values when we build the cost model for this particular container.
So Sean, if I understand that correctly, you're integrating into AWS APIs to get the cost data. So whether they're spot instances or there's a discount attached or reserved instances, whatever it might be, we're using actual numbers from the AWS API.
Correct. Yeah, we're using the AWS data exports to basically pull down the billing data for the customers to accurately reflect the pricing based on any number of the discount mechanisms that you guys offer.
Got it.
So from here, Webb talked briefly about the network cost monitoring. So we've done network cost monitoring for some time, basically just breaking down the costs based on the source and destination of that traffic. And we also added some ability to understand well, is this traffic destined for a cloud provider API or service, or just destined directly for the internet? The new version of Kubecost basically adds a visual element to that. So we have basically a network map here. So I'm filtered into one of my clusters here, and we're actually looking at the namespace view. This is an interactive view. So basically we can pull, we can move, we can zoom in. And you'll notice that there's a number of arrows, and the arrows kind of differ from a color and weight standpoint, if you will. And that basically helps you understand well, where is this traffic coming from? Where is it destined to? And then the weight essentially correlates to the cost of that data transfer. If we're to pick on a namespace, we'll choose Kubecost here and drill in. We get a nice view of all the different services that this particular namespace is interacting with. So we see some EC2, we see some S3, as well as some internet traffic. And then essentially we'll see a breakdown of those costs within the table below. And you can obviously filter and choose how you want to look at those costs based on what makes sense for how you want to look at that data.
This is really cool, Sean. This is almost like a service mesh level of observability where we're seeing, the way these components are communicating with one another. I had a question. Would this also account for, data transfer costs? Like if going between AZs, for example, or between data centers for the cost of the data itself?
Yeah, we'll show, and this comes with the billing information as well. So we're capturing the cost of that data transfer based on cross-zone, cross-region, and internet egress. And then when we ingest the bill, we essentially reconcile those costs, again, pulling in any of those discounts that the customer may be getting from AWS directly.
Got it. And we had a question come in chat. Does this include savings plans as well? And I'm assuming yes, it will.
Yep, as long as it appears in the bill, which last time I checked, savings plans do show up in the billing data. It will reflect those discounts from those purchases you've made via savings plans.
Excellent.
All right. The next thing, this is the one that I am probably the most excited about. And I actually talked with Webb directly about this when I first joined Kubecost a little bit over 2 years ago. And this is kind of the culmination of a lot of the different work we've been doing over the last 2 years. Collections is basically the combination of your Kubernetes application costs with the ability to also associate cloud costs to those specific applications. This environment that I've set up for the demo today basically shows you an application level view. So basically I've got this Acme Fitness application, I've got this Grafana application, and Kubecost itself. These are all what we call a collection. So basically a collection of costs. If I drill into, let's say, this Kubecost collection, you'll see that we're representing basically any Kubernetes costs where the namespace is equal to Kubecost. And then we're also pulling in some cloud costs. So namely, we've got some S3 costs related to the bucket. So basically where our metrics are being stored, as well as the cost and usage report. So we want to make sure we include all of those cloud-based costs with this actual application costs. So now we know the cost to run Kubecost basically contains those Kubernetes costs for the workloads running in the cluster itself, as well as those services running outside of the cluster that this particular application is consuming. One of the nice things about the way that we did implement this feature is you can aggregate just like other parts of our platform, specifically by collection. So in this example, I've got a few different applications, but you can also do it by category. So basically this adds some hierarchy. Think of a situation where like a cost center is inclusive of like 3 different applications. You can essentially build a collection for each one of those applications, and then you can create a category for that specific cost center. So now I can basically do cost-based accounting for those combined resources between Kubernetes and cloud. So looking at this application category, I can drill in and basically get the cost from all the applications within that particular category. Think of it like a tag, basically.
So Sean, would it be fair to assume that this is also kind of tied in closely with Kubecost reporting mechanism? So if you need to bubble this data up to the right department to show what each application or each sub-application costs, are they linked?
They are, yeah. So basically, as those users log into the platform, they'll, if they have RBAC enabled, so role-based access control for when they log in, they'll only ever see the costs that they're responsible for. And then additionally, we also have, obviously very robust APIs. So if the users want to extract this information and bring it into a third-party service like a dashboard of some kind, that is very much available as well.
And Sai, to that point, some of the things we're working on now are now adding the ability to have alerts and budgets and other functionality built directly on top of this. And again, I would say kind of 2 things that led us to this functionality. One is kind of unsurprisingly, a lot of teams using EKS are using other AWS services as well, and seeing that holistic picture is like hugely valuable. But secondly, we have some users with some really large counts of items or provider IDs in their bill, and so that entirely new backend allows this to scale to just massive cloud bills as well as Kubernetes environments.
Excellent. And we love to hear about the improvements being made in the backend, where maybe a lot of customers will just see the improvement as requests coming back a few seconds faster or even milliseconds faster, but you love to hear about those kind of enhancements being made in the backend itself. All right, Sean.
For sure, yeah. And say the last piece I want to highlight here is a really important concept that we're calling overlap. So obviously, as you can imagine, when you start to combine what we call domains, so basically Kubernetes is a domain, cloud is a domain. As you begin to combine those costs, there's going to be some overlap, right? Especially when you're talking about like EC2 or additional services being consumed, because basically the Kubernetes cost is a subset of that compute cost as well. So we do have some logic running in the backend that will remove that overlap. So you're basically not duplicating your costs when you're combining your cloud bill and your Kubernetes costs as well. And then the next piece is the actions. So I want to start with actions just by highlighting, probably our most impactful savings optimization, which is container request right sizing. Anyone that works in Kubernetes is very familiar with the difficulty to basically size your application appropriately, whether you're using something like Carpenter to scale your nodes or something like HPA, VPA to scale the actual applications themselves. The container right sizing request report is going to help you understand what you're actually consuming versus what you're requesting for capacity. And then based on a targeted efficiency, say you want to be like 60% efficient or 70% efficient, want to leave some overhead there. Kubecost will actually recommend what you should resize those workloads to basically maximize your efficiency, but while still leaving some overhead for scaling. And then Kubecost action basically brings in the ability to take action. So by default, when you install Kubecost, read only, and then Kubecost actions essentially allows you to define how you want to enable Kubecost to take action on behalf of you. We can do that by setting up auto recommendations, like a one-click resize, where you can come in here, pick the application you want to resize, or we can do full-on auto scaling based on a schedule or based on traffic as well. So you can basically allow the application to scale based on what it needs from an efficiency standpoint. And then we've also got namespace turn down. So think of a situation like over the weekend, you don't necessarily need some workloads running if maybe nobody's consuming them. So you can schedule that namespace to be basically shut off over a certain period of time. The cluster turn down as well. Say you've got a dev cluster, nobody's running it, it's not running any jobs over the weekend or maybe over the holidays. You can schedule that turn down as well. And then the request sizing piece, which we touched on, basically like auto scaling your applications directly via the Kubecost cluster controller.
I like the idea of having this be a controller. You don't want folks to just do ClickOps, right? This one-time action that you do through the console. You want something to be repeatable and continuous. So controller does seem like the right approach to implement something like this. We did get one question on this. Is the cluster controller enabled on primary cluster? I'm not sure I fully understand that, but perhaps they're asking if it's enabled by default or if it's enabled on the worker nodes or the control plane itself.
Yeah, that's a good question. So the cluster controller is an opt-in approach, so it's not deployed by default. We do take a read-only initial deployment approach. We know a lot of organizations are a bit leery to take action right off the bat, so they do have to opt in essentially to that controller being deployed. With regards to that caller's question, the Kubecost primary is basically the one that serves the UI and the API in the self-hosted product. So this interface rather is controlling the workloads on that specific cluster. But that being said, you can also control on other clusters. You just have to access the UI running on those other clusters.
Makes sense. And one other question that we got here, and this actually Sean might actually be more relevant to the previous tab here. Presumably nodes cost is attributed to the containers running on it. What happens with non-utilized costs of the node? For example, I think let's say you had one app that's taking 25% of a node, another app that takes 50% of that node. What about that remaining 25%? Is that allocated spread across the other two apps, or how does that work exactly?
Yeah, that's an excellent question, and I'm glad it was asked because I usually highlight it, but I kind of skimmed over a little bit here. You'll notice a gray bar in our charts here, and we basically tag that as idle capacity. You'll also see a corresponding row in the table below. We define idle as the slack capacity in cluster. So basically, this is the overhead that is neither being requested or consumed by the containers running on a particular node in a cluster. So basically, we would call that out as idle capacity. By default, we're going to show you what that idle capacity is, but those that are more concerned with like a chargeback type of scenario and they want to ensure the total cost of that cluster is attributed to all the workloads running within it, we do have the ability to basically charge that idle capacity back to a cluster by node, different use cases for different scenarios here. But basically, you'll see if I share by cluster, that idle line item has disappeared from the graph and the columns below. And then basically each cost for each container, or in this case, namespace running here, has proportionally increased to cover that idle capacity.
That makes a lot of sense. If I had to take a wild guess, I'd imagine if the idle section was pretty large for each node, I'm guessing one of your actions is built around helping reduce how much of your node is idle, right?
Yeah, for sure. It's a bit of a story, right? Because basically you want to resize the containers themselves. Once you've resized those containers, now you can actually resize the cluster to maximize your efficiency and realize the savings from that container right sizing.
Excellent. That makes sense. All right. What's next on the demo docket?
Yeah. So the last bit is pretty cool, and something that's been asked of quite a bit is, let's find my tab here, is forecasting. So a lot of the finance people obviously want to understand, like, I know what my costs are right now. Can you help me understand what my costs are going to be in 2 weeks, 30 days, 3 months, 6 months? So we've basically added a machine learning container to Kubecost 2.0, which is going to analyze your usage over a particular period, and then give you a projected spend basically for a period of selected time. So if I change my chart here to cost forecast, it's going to do some calculations in the back end here, and we'll see that I'm currently looking at the prior 30 days. for what we're calling realized spend, so spend that's already happened. And then I'm looking at the next 30 days for my projected spend. So basically looking at all the consumption over the past 30 days, we are projecting out what the potential cost of those workloads could be based on a forecasting algorithm. And then you also see in the chart below that we're basically breaking those down for you as well, the current run rate versus the high watermark and the low watermark of that projected spend.
So Kubecost is an AI company now.
No, not AI, machine learning.
Love it.
And this view applies not only to the allocation, so your Kubernetes workloads, but it can also apply to your assets view. So it's basically the underlying hardware of your cluster, as well as cloud costs. So you can basically look at the projected cost of your cloud costs based on that same machine learning.
Excellent.
And you can, of course, change the period of time you're looking back, as well as how far out you're projecting your spend. Right. And then the last bit, also a big ask from a lot of our customers is anomaly detection, right? So today, anomaly detection is focused on your cloud costs. So basically, as we ingest your cost usage report from AWS, we're looking at the previous period of time combined with the current period of time, and then identifying areas that are anomalous. So right here, we can see over the last 7 days, EC2 has increased quite a bit, right? We're doing a lot of testing on the new 2.0 infrastructure. And then now that we see this line item is a fairly large increase, we can essentially drill in here, which brings us over to our Cloud Cost Explorer. And now we can actually look over whatever period of time makes sense. And we can do a bit more investigative work to understand, well, why did that cost increase? What is essentially related to that percent of change?
Cool. And hey, on that last tab, now I know this isn't a new feature, but you showcased the different anomalies, and two of the services that I saw there were FSX and Athena. So I just wanted to call that out. Neither of those are Amazon EKS, and so you're pulling the cost of services that are even outside of EKS itself. Can you talk a little bit about how that works?
Yeah, correct. So all this data is derived from the cost usage report. So basically, we are interacting with the cost usage report via Athena. So we're querying for that data. And then as we ingest it, we basically identify if there's anomalous spend based on the services that appear within that billing data.
Gotcha. So you're not just tracking EKS, and of course, that's EC2 nodes and VPC, but also services that might be used by services running in that Kubernetes cluster. Things like FSX, for example, or Athena, like these other.
Correct.
Services.
Yeah. The new 2.0 backend basically allows us to ingest the entire bill. So we're basically expanding a bit beyond Kubernetes here with this anomaly detection.
Very cool. Very cool.
So
all right, Sean, you got any more demos for us? That was freaking cool. That was lightning fast. We saw so much of Kubecost in what was that, 10, 15 minutes?
Yeah. Again, calling out the pure performance increase, the speed change from the new backend is phenomenal. A lot of really good feedback from our existing customer base.
Awesome. Love to see it. So Webb, I want to turn it back to you really quickly here to talk a little bit about how our viewers can get started. And I know you shared that we've got an EKS optimized bundle that's entirely free for our customers to use. And comes with all of these features that you showcase with Kubecost 2.0. So what's next? How can folks get started?
That's exactly right, Sai. And I'll just, like you said, Sean, that was awesome. I know you went through a ton there really fast. Thank you so much for doing that. Sai, like you mentioned, you can install that today via the EKS blog post that's in the description. You can also get that AWS optimized version from kubecost.com. It can be Helm installed with a single command. We are now out there just collecting, feedback from users based on this tons of new functionality. And we're already, if you can imagine, shipping a release later this week based on that feedback we've already gotten so far. So we are fully focused on just, adding to this functionality based on users' needs. So reach out to us at any point. We very much welcome your feedback. Team at Kubecost, or even, I'm Webb at Kubecost. Feel free to reach out directly. To give you a little bit of preview for what's next, we've got a lot of things in the works. Like Sean mentioned, we shipped our first, machine learning, container. You can imagine we're going to be doing a lot more, with intelligence built on top of these, data feeds we have. As part of that, adding deeper GPU support, things like shared GPUs, GPU utilization, etc. We're also looking now to add a number of new, really impactful data sources. So you can count on, in a coming release of both Kubecost and OpenCost, adding a notion of carbon cost emissions. So not just financial costs, but any external carbon consumption, as well as other data sources when teams look to get kind of a comprehensive view of all of their kind of infrastructure cost. So stay tuned for that. But again, welcome all feedback on all of this new functionality. And again, just super excited to offer it to all EKS users as of today.
Awesome. And Webb, we did get a question in chat here from Michael. Is there an easy way to upgrade from Cube with the K, Kubecost 1.0? Of course, from 1.0 to 2.0, there's an expectation there's going to be new software to install. What's that migration process look like?
Yeah, we have worked super hard to make this a seamless transition. So for most teams running default Kubecost, it will just be a Helm upgrade. Where there's a couple scenarios where if you have, say, Thanos enabled, or you're writing data to an S3 bucket in a certain way, that our Helm chart will prompt you to review a migration guide. Those are kind of like single-digit percentage users at this point, and we're working with a lot of them directly. You can go see that migration guide directly in our docs, and we can get the link after here. But for let's say 98+% of users, we wouldn't expect that to be needed, and it will simply be a Helm upgrade. So thank you for the team to working super hard to making that a seamless transition. If you do run into any hiccups, please reach out at any point. We want to help you every step of the way. But it should be, again, retaining data, smooth transition.
Excellent. I will link that in the description below and right here in the comments as well. Webb, Sean, anything else that you want to leave our viewers with today?
This is amazing. Thank you. Thank you so much for having us, Sai. Just we're so proud to share this with your community, and look forward to any feedback and improvements. We are standing by to again address any feedback, and know that there'll be more coming from us soon in the areas we mentioned.
Excellent. Awesome. Well, thank you so much. The pleasure is all mine, Webb, Sean, for joining us on Containers from the Couch for that awesome demo, Sean, and the overview of Kubecost 2.0. Folks, be sure to subscribe to Containers from the Couch to find more episodes like this in the future. Thank you all for joining us. Goodbye.